Hello, I'm Toras.
And I'm Lisa from Germany.
This is Erasmus Plus project, and now we are in France, in Évreux. Now it's October 2016, and our goal is to produce electricity from waste paper.
I will give you a short overview about our lab work. First, we are doing the hydrolysis of cellulose to glucose by enzymes. Our next step is an anaerobic fermentation to produce ethanol. To get real pure ethanol, we need to do a distillation. And our last step is the electrification with the help of a fuel cell.
Hello, I'm Katerina Vanica, I'm from Hamburg, and today I'm going to illustrate you the cellulose structure. Here you can see the glucose molecules, which are together because of the glucose bonds, and these keep those molecules together really strongly. Then you have the hydrogen bonds, you can turn around. And those hydrogen bonds are not as strong as the glucosidic bonds. So if you cut a paper like this, you destroy these ones. Here you can see a linear structure, as you see on the paper.
Get some ethanol from wood.
The wood is made in a autoclave in 170 to 190 degrees with water and ethanol. The lignin and hemicellulose is in a solution, and the cellulose is in the solid phase on the bottom of the flask. When we put water in the solution, we can see the lignin and hemicellulose is separate, and the lignin goes to the bottom of the flask.
So I will tell you something about the hydrolysis with the help of enzymes. You can see here the cellulose with the COC glycosidic bonding. We add the enzyme cellulase, which breaks down this bonding so that we get some cellobiose and glucose. The problem with cellobiose is that it inhibits the cellulase. So we add another enzyme, the cellobiase, to get more glucose.
Hello, I'm Paul from Austria, and I will give you information about the second step of our experiment, the fermentation. So we are using yeast to fermentate our glucose to ethanol, and the exact name of the yeast is Saccharomyces cerevisiae, which is facultative anaerobic. That means it can both grow under aerobic and anaerobic conditions. But we want to produce ethanol, and that is why we need anaerobic conditions, because our yeast only produces ethanol under anaerobic conditions.
So as you can see here, we have a graph. On the x-axis we have a time in hours, and on the y-axis we have a concentration. Yeast uses glucose to produce ethanol, so as the time goes by, the concentration of glucose is declining and the concentration of ethanol is increasing.
Hello, my name is Tristan and here is my partner.
My name is Rosanna and I'm from Germany.
So I'm going to present the different equipment of the distillation process. So first we have the safety goggles to protect your eyes from any projection. Here we have the Bunsen burner to heat the liquid on the NMAF flask. On top we have the thermometer, which measures the temperature of the steam. Here we have the cooler, and here we have the beaker to contain the drop.
Okay, we heat up our mixture of ethanol and water with the Bunsen burner. The steam goes up and we measure the steam with our thermometer. We have 78 degrees, that's the boiling point of ethanol. Then our steam takes its way into the cooler. Into the cooler it cools down and we have a condensation, and the ethanol, the pure ethanol, drops out in our beaker. Then there we have now an ethanol with a percentage of 95%.
Hello, I'm Lucas from Austria, and I'm going to explain to you the principle of the optical density measurement. So we have here our light bulb, or light, we have here a solution of yeast cells, and we have our photocell over there. Now, if the solution has a low amount of yeast in it, light can easily pass through to the photocell. Then the light is afterwards measured by the photocell. But if the yeast solution is thicker, so the concentration of the yeast is higher, light can't pass through. So it is scattered, and no light is measured at the photocell.